The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All righty. So today we're going to start a new chapter or objective or whatever you want to call it. It has to do with graphing, plotting points, drawing lines, all kinds of fun things. So let's go ahead and get started. So if this was a regular classroom, not Zoom or this way, we are all in a classroom together, I would have you get some graph paper, which is paper that has a whole bunch of little squares on it. And I would have you create graphs by drawing what is called the x-axis, which is a horizontal axis, and a vertical axis, which is called the y-axis. Each of these axes, or whatever, however you say axi, whatever plural, has a scale. Notice, let's back up here a minute, that I have a 5 marked off, and there's 1, 2, 3, 4, 5. So the scale implies that on the x-axis, each square is 1 unit. The same thing is true on the y-axis. Now, it's possible to have different scales where 1 square is 2 units or 5 units or 10 units. You can even have a different scale on the x-axis than you have on the y-axis. It just depends on the data, the information that you're going to plot. All right. This whole thing has several different names. It's called the rectangular coordinate system. It's called the Cartesian coordinate system after a mathematician whose last name was Descartes. It's also sometimes called the XY plane or the grid. There's all those different names referring to this whole thing here. All right. Now, we're going to be plotting points on this graph. And to plot a point on a 2-dimensional grid, you need 2 pieces of information. If you've ever played the game Battleship, you have, it's like letters going across the top and numbers going down, and you give 2 pieces of information. You might say G7, and then you go over to G and down to 7, and that's where G7 is. But there's 2 pieces of information. Or maybe you've never played Battleship, but you've been in a big city and you have a map and you're trying to locate something. Of course, anymore, you just type it into your phone and it would tell you. But back in the day, you'd turn the map over and it would have, like, you're looking for Jones Street, and it might say E6. And again, like with Battleship, you'd go across the top of the map to where you found the letter E and down to where you found the number 6. But again, it takes 2 pieces of information to locate a point on a 2-dimensional grid. Now, those 2 pieces of information are called the x coordinate and the y coordinate. Helps if I could spell. And they are listed in an ordered pair that's inside parentheses, and the 2 values are separated by a comma. So this is the ordered pair that describes a point on the graph. The x coordinate comes first, always, so that is a 2. The y coordinate is a 3. So on the graph, on the x-axis, I will go over 2 units, and then I'll go up 3 units on the y-axis. So right there is the point with the coordinates 2, 3. Any question about that point? All right, let's plot another point, 4, -5. So 1, 2, 3, 4, 1, 2, 3, 4. Right here is 4, -5. Again, any questions there? Okay, how about -3, 6? So over here is -3 and up here is 6. So there's -3. Put those two close together. -3, 6. And let's see, how about this one? -2, -1. -2, that would be right here. Now, the point where the X and the Y axis intersect right here is called the origin. The coordinates of the origin are 0, 0. Any questions about that? Okay. The whole grid, the whole rectangular coordinate system is divided into 4 quadrants, and we use Roman numerals to label them. Quadrant 1, 2, 3, and 4. Notice they are labeled in counterclockwise fashion. Also, take a look at quadrant 1. Can you see in quadrant 1, all the X values are positive and all the Y values are positive? So all your ordered pairs would have positive X and Y coordinates. Quadrant 3, all the X values and the Y values are negative. So a point in quadrant 3 would have a negative X value and a negative Y value. In quadrant 2, X is negative and Y is positive. In quadrant 4, X is positive and Y is negative. Any questions about that information? All right. Let's go to WAMAP. So let me change my screen here. And can everybody see the WAMAP screen here? Does somebody tell me yes if you can? Yeah. All right, just want to make sure I push the right buttons. It says plot these points. Yes, I knew I forgot something. Let me go back for a minute. So we could take these points and instead of listing them in an ordered pair fashion, we could list them in what is called a table. And it would look like this. So you've got sets of ordered pairs, but written in a table form. Okay, any questions about that? Well, let's try again here. So here we have a rectangular coordinate system. It says plot these points and they're listed in a table fashion. Now, I'll click on draw dot. And the first point is 4, 4. So the X value is 4 and the Y value is 4. And so there's the point. Okay. That doesn't look like it's quite on there. So what I can do is hover over it till I get the little cross and I can move that point wherever I want. And there we go. Okay. Then 7, 7. Let's see here. 7, 7. 2, 3. 5, 1. And 6, 6. Oh. It gave me a yellow check mark. Well, what that means is that it's partially right, but not completely right. I need to get a green check mark. So I got to go back and look. And if any of you were watching, I plotted this point incorrectly. So let's go back and let's move it to the correct place, that is. And now let's submit it. The problem is, though, the yellow check mark will say it's not all right, but it doesn't tell you which pointer points are wrong. So you got to go back and kind of figure that out. Anyway, Any questions about this example? All right. Now we're going to go the other direction, where instead of plotting points, we have a point. We are to determine the X and Y coordinates of the point plotted. So the X value would be 2. And the Y value would be -1 because it's down below. So -1. Okay. And so that's correct. Any question about that? Let's see what happens if we make this wrong. Oh, this is okay. Let's see what it says. So it tells me which part of the coordinate is incorrect. So that's good. I can go back and correct it. All right. This is basically the same thing. The X value is -2. The Y value is 3. Any questions there? All right, so here's more of the same kind of question. Let's see. Now we're back to where it just gives us a single point to plot. So plot the point 3, -4. Okay, and again, if I need to, I can move it around. Any questions there? All right. It says plot the trapezoid with corners at the points. Let's go back to the other screen for a minute. And let's talk about what a trapezoid is. A trapezoid is a quadrilateral. That means it has 4 sides, but there are exactly 2 sides that are parallel. Now, my lousy drawing, this is supposed to be a rectangle. A rectangle is not a trapezoid because these 2 lines are parallel and those 2 lines are parallel. It has exactly 2 lines that are parallel. A common trapezoid, I believe that somewhere on campus we have trapezoidal tables. So you've got these 2 lines are parallel, but these 2 are not. Okay, so that's kind of what a trapezoid looks like. So let's go back here. And now, here, notice it doesn't say dot like it did on the previous ones. It says line. So what I'm going to do is I'm going to start by plotting the first point, -2, -1. Okay. But now I'm going to go from there to the next point, which is -1, -3.
The
The
first
first
one
point
was
is actually -2,
1.
1.
Thank you.
+1.
Thank you. Well, by golly, it's a good thing I can clear it up here.
You were pulling me.
Well,
You were
once
pulling
again,
me.
this proves that I can't walk and chew gum at the same time. All right, so -2, 1 is right there. Now we're going to go, oh, that's weird. Oh, okay. So what happened there? Well, I was dragging it. So what I've got to do is I've got to click there, and then I'm not holding down the mouse key, right? That's why it was dragging before. -1, -3. So then I'm going to click there and let off the mouse key. 0, -3 would be there. So click, and then 2, 1, click, and then back to the beginning. Oops. Apparently I was holding the mouse key down. Well, shoot, am I going to have to start all over? I guess so. So this thing's kind of sensitive. -2, 1, click, release the mouse key, release the Kraken. -1, -3. So I'm going to click there, release it. 0.
No.
Oh, I'm screwing up again, aren't I?
Yeah,
Yep.
one over to the left.
Well, you know, and my point was to show you that this is kind of tricky, and I guess I'm doing a good job, aren't I? Honestly, when I practiced this yesterday, I did it right the first time. -2, 1, click. -1, -3. So now I'm nervous that I'm going to mess up, and you're all watching me. 0, -3. 2, 1. It only took me, what, 16 tries? But my point is, this thing's really sensitive. So you click and then release it, and then you get to your next point, and then you click and then release it, and you get to your next point. I kind of like that, okay? So that's a little bit tricky. And just plot them in order. And when you get to the last point, you've got to come back and reconnect it. Okay. Plot the points. That's just plotting points. We've done that. We've done that. Oh, let's do one that has a improper fraction. So dot 0, 0, -3, +3, 3, 7/2. Well, they don't typically use a mixed number in an ordered pair. They might use a fraction, a proper or an improper fraction. They might use a decimal. So they could have used 3.5, but they typically don't use a mixed number. But 7/2 as a mixed number would be 3.5. So I'm going to go to 3 and then up to 3.5. Okay. Any questions about that? And then 5, 2. So let's see what it says. Yay. All right. Any questions there? Let's do one more. So the 9/2 would be 4.5. So 4.5, and then down to -3 would be right there. Okay. And then, of course, we'd plot the other points, but I'm not going to bother doing that. Identify the points from the graph. Let's see here. A is what? 1, -2. Now, here's a tricky thing. So 1, -2, I'm going to click here. If I just put in 1, -2, it says invalid notation. What I need parentheses. If I use, oops, I could use the parentheses on my keyboard. I've got 1, comma. Oh, but look what happened when I pushed the space bar. Because ordinarily you would type it, if you were just, not typing in WAMAP, you'd put in parentheses, 1, comma, then a space, and then the next number, and then a right-hand parentheses. But in WAMAP, if I push the space bar, it takes me outside of the parentheses. So let's see, what is it? 1, -2. So I'm going to put in -2, and then my right-hand parentheses. Okay. Now, another way I can do this, rather than using the parentheses on my computer keyboard, I can click on that button. And let's see, 0.2 is what? -2, 3. So -2, comma. Again, don't put any space in. Well, let's see what happens. Nope, it doesn't like it. And there's the next point. Okay, so again, you've got to kind of get used to the WAMAP notation. Don't give up and pound your head on the floor. Not a good thing, but anyway, and then what? C would be 1, 4. So 1, comma, 4. And D is -4, -5, -4, comma, -5. But you've got to have parentheses one way or another and a comma separating the two numbers. Okay. Any questions there? All right, now we have what's called a scatter plot. And a scatter plot is where you've got a whole bunch of data that's been collected, and there may or may not be some pattern to it. So you plot it all on a graph, and maybe it all lines up into a nice straight line, or maybe it forms a curve that can be described by some equation, or maybe it's just a bunch of random points that have no correlation whatsoever. But the beginning of that involves plotting a bunch of points. So that's what we're going to do here. So this says the following table gives data comparing the number of calories in a serving of breakfast cereal and the number of grams of total carbohydrate also contained in that serving. Create a scatter plot below. So this is not going to be a bunch of connected dots. It's going to be just a bunch of dots. All right. So my first point is at 180, 24. So 180 here. 24 right there comes over 180, 24 is right there. Okay. Then 130, 26. So 130, 26, 239. So here's 38, here's 40. So 239 is right about there. 227 would be there. 140, 35. Here's 140, 35 is halfway between 34 and 36. 140, 26. I'm going to move that over just a little. Maybe not. 160, 39. 227. We've got another point there. I guess I can't plot. It won't let me plot them both. I mean, it doesn't show up there. 100, 28. Let's see what happens. I'm going to make that last point incorrect just to see what happens. Okay, so again, it's giving me the yellow flag saying it's mostly right, but not completely right. But it doesn't tell me which point is incorrect. So I'll come here and move this down here to where it goes. And now it's all correct. Yeah, again, it's kind of a bummer that it doesn't tell you which point. Anyway, here, kind of going the other direction, we already have the scatter plot. Can you see that it kind of forms, it's not a perfect straight line, but it's sort of linear. It forms a fairly straight line. So we could use this to predict some things. We might say, well, there's a trend that seems to be going about like this. And so we might say, oh, we would predict that out here at year whatever, something would happen there. Okay. So that's kind of how we use a scatter plot to predict things outside of the scatter plot area. All right. Now, during what calendar year or years was the average price of the commodity 56 cents per pound? Okay, so let's see here. It doesn't really, we have the year here, and here it doesn't really have a label in cents per pound. It would have been nice if it had, but I guess we're going to have to make some assumptions. So 56 cents per pound would be there. So that was in what, 1996? So 1996. Okay. Let's see here. Is it going to let us? Hang on. Got to move things around. There we go. Sorry, the screen with all of you people was blocking my view here. Let's put you up here at the top. All right. During what calendar years was the average price of the commodity 58 cents per pound? 58 cents, there's one value, and that's 1997. Okay. I'm going to do another one of these. Let's see if it, that's not doing it. Sometimes there'll be two, here we go. For instance, if it said, oh, good. Yes, this is what I wanted. When is a commodity 51 cents per pound? Well, both 1992 and 1993. See there? And then during what calendar years was the average price 61 cents per pound, that would be 2,000. So this whole assignment is pretty much on plotting points or identifying the coordinates of points on a graph. All right. Do you have any questions before we go? All righty, I'll go ahead and stop the recording.